You have to start the MATLAB programming for the Laplace transform. You have write a program for to find out the Laplace transform. Laplace transform you have also studied in the mathematics class. Then you have and the Laplace transform in the MATLAB. MATLAB, how to write a program in the MATLAB to find out the Laplace transform. There is the basic codes to write a given Laplace transform of a given signal. Write simply you have find out you write in the notebook. Simple you choose a script in a window, editor window, and write a code for finding the Laplace transform. Simply you have write a code to find the Laplace transform of exponential signal. Laplace transform of exponential signal. You have also know the Laplace transform of the exponential signal. You have also know in the mathematical class, in signal processing class, in the introductory section, to find out the Laplace transform of the exponential signal. The exponential signal is also a test signal, standard signal. Then you have write a comment on the top of the editor window and write a code to find out the Laplace transform. There is some notations are used and declarations in top of the editor window, like SYMS. This is a symbolic toolbox, and declare the variables like time, a, and the variables and the s. This is symbolic notations are used in this function. And then you have write a code to find out the Laplace transform of the exponential signal. Simply you have write the exp, means you have to find out the Laplace transform of the e to the power at. Simply you have write a code. Simply suppose this is the signal xt is equal to e to the power at. Simply then this is the question, the Laplace transform, write a Laplace transform of a exponential signal. Exponential ex, this is the exponential signal can be denoted by ext is equal to e to the power at. Then you have write the code in the MATLAB. Then you have write x is equal to exp. This is the subscript used in the MATLAB. Exp in bracket e to the power at. This can be also written in the bracket minus a. Multiplication can be denoted by star and t. The bracket close. You have also seen the basic, and there's a semicolon. Close the. This is ext. You have also typed the correct notation. This is a middle bracket ext, and then enter, and then called as variable s. S signify the Laplace transform of this given signal, and this can be also written x is equal to LA Laplace LAP LAC in bracket x. X is the input, then enter, and then result is displayed in the command window. Result is display on the command window also. Result is display on the command window is hidden here. Then the basic function here, the basic command can be written in the simple can be written as ex into there is some another file is open, then your command window is hidden inside the you write this code on command window and run it directly in the command window. Here the syntax error is you have written the SYM. Correct word is, that's why there is a error in the file. This is the typos error. Here I have written this typos error SYMS. This is symbolic toolbox. Then you have run it, and this is the file name. This is the written Laplace transform. Here you have this notation is not visible here. Visible. This is the extension of the file name. You have written the file name. You have lap.m. lap.m. Then you have seen the result. There is some error also because there is some syntax are missing. You have written SYMTS. There is some error in typing SIMS, SYMS, TA, capital S, EXP, and then this can be written on the directly on the command window. You have write the CLC, clear the window and close all the codes. Write a command, close all and clear all. These are the basic command, clear all, and then write the code of Laplace transform. Here line here is the missing it is missing in the symbolic parameter. Symbolic toolbars are missing, that's why this error is occur. Here is the one more thing is missing here in the notation. You have written the bracket is missing, that's why here you have corrected here the double bracket are S is equal to here, there is a double, then you have put this clear all CLC and then write the code Laplace. I am missing some e to the power s ts, some error in spelling LAPLACE to x. There is some syntax error. Then you have try once again. Then you have debug the error SYMST. Here here the syntax is missing. That's why you have commented, and SYMST small t A and then capital L not applicable. This is sensitive for the case L. Then you have run it. Again there is some syntax error. You have repeated the command CLC and then putting this command in the command window and then run it and find out the result. It is the standard result of the Laplace transform. There is some error in typing the code. That's why there is some typos error, there is syntax error. That's why you have, there is two-line command. One is declare the input variables and then you have put the right command in the Laplace. You have right syntax. Then there is a one, it is the symbolic toolbox syntax. SYMS, you have declared the variable TAS and T suffix the time variable, time. T signifies the time, A is the constant, as is the symbol used for the Laplace transform. Then you have defined the syntax top of the command line. This is a simple notation. You have also used in the C. C is also using some predefined files and some more syntax. Header files are being defined. But here there is a no compiler, then you have no formality to write on the predefined files. They simply you have write the codes, simply you have write the formula in exact manner in the MATLAB. There is a simple you have written in this mathematics formula xt is equal to e to the power at. Then you have written in this MATLAB, you have written x is equal to exp, in bracket you have written minus a multiplication t, star is signifies the multiplication operators and t, and then put the built-in command in the MATLAB. You have also used the built-in library functions in MATLAB. Then you have used the Laplace x, then s is equal to Laplace x. Then you have also find the standard result of the exponential function Laplace transform. Here you have also know by using the direct Laplace transform of this standard signal and compare it, there is similar result 1 upon s plus a, yeah, a plus s, this result. Then here you have cross-checked the result by using directly calculating the Laplace transform by using formula, and then you have directly calculating the Laplace transform by MATLAB. This is simple. Notations and direct commands can be used to find out the Laplace transform of this standard signal. Then you have also find out the Laplace transform of another signals like sine signals, cosine signals, and impulse function. Then you have find out the Laplace transform of the sine signal. There is same process follows in another signal, but your syntax are being notations are different. You have find out the Laplace transform of the cosine signal. Then you have edit in this command window. Here you have write the expression. You have write the x t is equal to there another signal can be written. This is the Laplace transform of the impulse exponential signal. Then you have write the Laplace transform of the cosine x t is equal to cos omega t. This is the question. Then you have write the MATLAB code of the cosine function. Then you have write the MATLAB code. This simply you have changed the script by using exponential. You have written cos, COS, and you have written the variable. This is the W star T, and you have added the variable name. You have S is the same. You have also T, and yeah, you have written a W. W can be used in this, and this is S is equal to similar. You directly run in the command window and enter and find out the Laplace transform of the cosine transform. Simply you have also know the S upon S square plus omega square. This is the result. You have also know the standard result of the Laplace transform of cosine function. You have also know. Simply you have calculated the Laplace transform of this function. This can be also written as by Laplace transform by using direct math in Laplace domain by using individual by dividing by the Euler form, and individually you have find out the Laplace transform e power j omega t plus minus e to power j omega t and add on, and then you have find out the Laplace transform of this signal can be s square plus omega square. This is the standard result of the Laplace transform of the cosine function. You cross check the result. The simple operation by using the Laplace transform by using MATLAB. Simple commands can be used to find out the Laplace. Here command is Laplace, and you have this notation can be used with symbolic variables toolbox. These symbols are being included in this built-in library function. Here there is a built-in library function. You have also used the built-in command, not a user-defined function. These are the standard function. Then MATLAB can directly use this function. This is a standard function. You have also know the basic criterion to find out the standard result to cross-check by using the direct calculation of Laplace transform, simple conventional approach, and then you have find out the Laplace transform by using the MATLAB. These are the easy steps. You have the cross-check the results, and then you have also find out the Laplace transform of various signals. Then you have find out the another Laplace transform of any signals, like you have a sine function. You have also simply another cosine domain functions are being written as. You have check this result. This notation can be changed. This is sine. Sine and cosine, you have also know the behavior of sine function and cosine function. Then cross check this result. Then you have added the input variables, input syntax. You have write the sine instead of cosine function. Then change the input command. You have changed the sin, yeah, and then you put the Laplace transform. Simply you have write in the command window, then you have cross check this result. Simply you run in the here. This is also the Laplace transform of this sine function can be written as x is equal to omega upon s square plus omega square. You have also know the standard result of the sine cosine function Laplace transform. You have already cross-checked this result by taking individually Laplace transform of this function. Here there is two steps. Generally there are three steps. One is denoting the syntax of you have defining the variables and sym, this is symbolic function toolbox. Their symbols are used in this function, then you have donated in the top of the line. And here this is the simple notation of the sine cosine function. This is the standard mathematical functions. This is built-in commands. Built-in means you have use the standard commands inbuilt in the library of the MATLAB. You have not defined any such type of command. This is the inbuilt command. जैसे कि आप एप्स को यूज करते हैं कि सब उसमें आपके यूजर डिफाइन या आपके जो फंक्शन जो हैं आपके टास्क को इजी बनाने के लिए रहते हैं कि आपके ऐसे सिंपल बटन्स बनाए होते हैं, केवल इनपुट दीजिए और आउटपुट मिल जाता है, यूजर फ्रेंडली. ठीक है. इसके जीयूआई भी होते हैं, ग्राफिकल यूजर इंटरफेस, जिसमें आप कोडिंग को न करके डायरेक्ट आप एक ब्लैक बॉक्स की तरह इनपुट दीजिए, आउटपुट आपको मिल जाएगा सिमुलेट करके. बैक एंड में आपका कोडिंग होगा लेकिन वो नहीं दिखेगा, आपको रिजल्ट दिखेगा, आउटपुट दिखेगा. जैसे आप किट पे चेक करते हैं ना लैब में, आपको इनबिल्ट आपका इंटरनल सर्किट डायग्राम नहीं रहता, ऊपर का रहता है और नीचे क्या हो रहा है सर्किट ऑपरेशंस. आपको इनपुट दिया, इनपुट वायर दिए हैं नॉब्स में, आप प्लग इन किए, आउटपुट आपने डिस्प्ले में कनेक्ट किया, आपको साइनसॉइडल रिजल्ट आ गया. जैसे हाफ वेव रेक्टिफायर, फुल वेव रेक्टिफायर या एम्पलीफायर्स के केस में आपको इनपुट को कनेक्ट करना है, आउटपुट को डिस्प्ले में जोड़ देना है, आपको रिजल्ट आ गया. तो उसी तरह से यहां पे हम यूजर डिफाइन नहीं, हमने बिल्ट इन फंक्शंस को यूज करके आपके ये फंक्शन का डायरेक्टली कोड हमने निकाल लिया. ठीक है. दीज आर द बेसिक फंक्शन लैप्लास ट्रांसफॉर्म. लीजिए. तो ये आपके Laplace transform of this standard functions. Then there are another Laplace transform of the like factorial function xt is equal to t power n. Another Laplace transform can be find out. Xt is equal to t power n. How to find out the Laplace transform of this function? Can be computed by simply changing the variable. Here your some other notations can be used in this command window. Here there is t power, here you can define n, the suffix n. S is also defined, and then you have defined the x, and x is equal to x t cap t power n, cap n. Power can be defined by cap n, and then this is the Laplace transform of the t power n. Here I have written CLC, clear the window and close all and clear all, and simply type the command on the command window and enter it. This is the piecewise, this is the expansion of this t power n. This is a factorial representation, then can be written as in this form. ठीक है. Another hyperbolic, sine hyperbolic t. There's another यहाँ पे आपका और लिखा होगा, देखिए ये होगा ना, ये पूरा एक्सपेंशन होगा. पीस वाइज आप निकालेंगे तो ये गामा वो एक्सपेंशन होगा ना, t के पावर n का लैप्लास ट्रांसफॉर्म निकालेंगे तो जनरलाइज जो एक्सपेंशन होता है सीरीज का उस तरह से. देन अनदर क्वेश्चन इज टू फाइंड आउट द लैप्लास ट्रांसफॉर्म ऑफ hyperbolic function. Then your hyperbolic function means you have defined xt is equal to sine ht. St is equal to, there is some another transfer function, standard functions like xt is equal to sine ht, and you find out the Laplace transform of this hyperbolic function. This function can be also find out, the hyperbolic function can be find out by simply changing the syntax. There here you have symbolic variable t and n, not suffix. You have used t and it is not useful. Here a s s, here the hyperbolic function can be also sin h a star t. Simply, this is a hyperbolic function. The hyperbolic function can be also find out the Laplace transform of the hyperbolic function. Xt is equal to sine at. Sine at, sine ht, sine ht. This can be find out the simply h is missing. यहाँ पे देखिएगा लिखा हुआ सिंटेक्स में क्या, sin h, हाँ h है उसकी इन ब्रैकेट 80. This is the Laplace transform of the hyperbolic function. Then you have copy on the command window and directly run in editor window. The result is given, but you have also you have written clc command to clear the command window and close all the program. Close all and put the command in the command window. Is simply testing the, this is a simple result. You have cross checked the result sine ht. This is the standard result. The Laplace transform of this hyperbolic function minus a upon s is a square, क्या कहते हैं, a square minus s square. Simply this hyperbolic function, the standard result of Laplace transform of hyperbolic function can be written as this form. This is a standard result. Simply you have written the Laplace transform of the another hyperbolic function xt is equal to cos ht. ठीक. Simply you are changing the input command, input signal. You have written sine instead of cos ht. Then you have changed the syntax. Simply you have changed the syntax. Cos h, ठीक है, cos h a n t है. Simply you have CLC. This is the standard result of a hyperbolic Laplace transform of this hyperbolic function can be written as, this can be represented as minus s a square minus s square. This is simple result. You have written a s square minus a square ना, बुक ऐसे लिखा होता ना, तो इस तरह से लिखा है. दिस इज एग्जैक्ट रिजल्ट. You find out the standard functions, Laplace transform. Simply, this is the basic commands used for solving the standard signal Laplace transform. स्टैंडर्ड सिग्नल्स के हम लैप्लास ट्रांसफॉर्म कैसे डायरेक्ट बिल्ट इन फंक्शन को यूज करके हम वन लाइन में, टू लाइन में हम कोड का रिजल्ट निकाल सकते हैं, जो आप 4-5 लाइन में निकालते हैं मैथमेटिकली या मैनुअली करते हैं. जैसे आप मैथमेटिक्स में या सिग्नल इनमें लैप्लास ट्रांसफॉर्म जो पढ़ाएगा, जो फार्मूला है उसके बेस पे आप करेंगे बाय यूजिंग प्रॉपर्टीज. तो यहाँ पे आप डायरेक्ट ये तो नहीं बताया हमने, तो वन लाइन में, टू लाइन में या 3 लाइन है, बेसिकली 3 लाइन कोड्स है. 3 लाइन कोड्स में हमने इसका रिजल्ट निकाल दिया. ठीक है, तो आपका जैसे कि ये काम आपका आसान हो गया. आप क्रॉस चेक कर सकते इस तरह से. अब और भी बड़े इक्वेशंस हैं, डिफरेंशियल इक्वेशंस को भी सॉल्व कर सकते हैं बाय यूजिंग बिल्ट इन कमांड्स. ठीक है, ऑर्डिनरी डिफरेंशियल इक्वेशंस को भी हम लैप्लास ट्रांसफॉर्म के थ्रू सॉल्व कर सकते हैं. ओडी फंक्शन है. ठीक है, तो these are the uses of the Laplace transform in the signal processing. It is a basic use of the Laplace transform to solving the this standard signals like exponential, sine, cosine, hyperbolic functions can be simply solving by these standard commands. Then you have, because these are the standard mathematical function, that's why MATLAB is the matrix laboratory. The MATLAB is used for the mathematicians, you have used for the scientists, you have used, MATLABs are used for the researchers. That's why these are the built-in commands in the library. There are various mathematical functions are being stored in the library. There are 2 types of functions. One is built-in, another is user-defined. Then user-defined function is defined function is one type of function. Then you have defined for your requirements. अपने सुविधा अनुसार आप जो फंक्शन बनाएं, जो कोई भी आपने फंक्शन डिफाइन करे, उसमें आर्गुमेंट आप पास करें. मीन्स आपके वेरिएबल्स, क्या क्या आपके वेरिएबल्स होंगे, इनपुट आउटपुट. तो उस तरह के फंक्शन आपके डिफरेंट एप्लीकेशंस के लिए, कुछ जैसे आप कोई रियल टाइम टास्क कर रहे हैं या कोई ऐसा कर रहे हैं जो कोड नहीं एग्जिस्ट है, तो उसके लिए आप, इसमें फैसिलिटी है कि आप यूजर डिफाइंड फंक्शन को भी बना सकते हैं. उसके लिए कुछ रूल्स हैं कि आप जो फंक्शन बनाएंगे उसी नाम से फाइल को हम सेव करेंगे. ठीक है, आप करेंट डायरेक्टरीज में, क्योंकि जब उस फंक्शन को आपको कॉल करना हुआ तो उस नाम का ही फंक्शन, जैसे आप कोई फंक्शन बनाए मान लीजिए xy, ठीक है, तो फन नाम से आप उस फंक्शन को डिफाइन करेंगे और उसमें जो आर्गुमेंट होगा कि वो क्या करेगा, क्या उसका मैथमेटिकल फार्मूला है, अंदर क्या ऑपरेशंस है, सेटअप रूल क्या है, वो अंदर डिफाइन होंगे. इनपुट आउटपुट आर्गुमेंट्स आपके डिनोटेड होंगे. ठीक है, तो दिस इज द अबाउट द मैथमेटिकल फंक्शंस या जो स्टैंडर्ड सिग्नल्स हैं उनका हम लैप्लास ट्रांसफॉर्म कैसे इजीली 3 लाइन में हम निकाल सकते हैं. तो these are the uses of the MATLAB. There are various uses of the MATLABs in the signal processing domain. These are the basic examples. Then you have find out the inverse Laplace transform of this given functions. Like simple, you are taking the inverse commands to find out the inverse Laplace transform. You have also find out the partial fraction expansion. There are various uses of the Laplace transform in the transform domain analysis. There is various built-in commands in the Laplace transform. That's all. This is the all about the Laplace transform. In next class, you have discussed the inverse Laplace transform and Z transform and Fourier transform. This is the basic idea about the Laplace transform. Then you have studied the basic background of the Laplace transform in inverse Laplace transform in next class. Thank you.